This spreadsheet is attempting to learn the difference between fighting and dancing. The two figures here are randomly generated, and I've made about 600 of them, and I've categorized them as either fighting or dancing. And if you look at my classification versus what the computer thinks, it's pretty good. I've got to, well, it depends how you look at it, but up to 90 or 100% accuracy on trained data. But when you transfer that to testing, it's okay. I get up to about 84%. So there seems to be some basic characteristic which, although as a human I don't think we can really describe what the difference is between the fighting and the dancing figures, but we can instinctively and kind of instantly say, well, they're fighting and they're dancing. And that's arguably not fighting. Anyway, I categorized it previously as dancing, and the spreadsheet is now tracking it. Now, that's based on a neural network that's spread across, well, one sheet, and it looks at 100 of these. It looks at 100 of these cases in one go, and it runs them through a 3-layer neural network: layer 1, layer 2, and layer 3 down here. And on the dashboard, you're looking at those layers, but they're not active now because we're not actually training it. When we test it, we run it through a much smaller network. So here is the vector of, it should be actually 40 x and y coordinates, so 40 total coordinates in a vector, and that represents 10 dots per figure. And if you look at the data where I created this is randomly creating the figures. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots per figure, and they're just being spewed out of this bit of code, and it's effectively the head, and then the neck hangs from the minimum of the head, and then depending on a random adjustment, the arms and legs wave about slowly, but it gives you lots of possible combinations. And I went through, as I said, made 600 of these, and categorized them, which was clearly a slightly deranged thing to do. And we're looking at the categorized version of one mini batch. If I stacked all of these up together, so when I'd categorized them, I decided which was dancing and which was fighting. And this is the sum of all the dancing patterns for 100 cases, and the sum of all the fighting patterns. Now, it's not particularly obvious to me if there's a strong difference between fighting and dancing by these patterns, but the spreadsheet's going to find out what it looks like. If I just wipe out I'll initialize this so that it has no memory, and if we now go through, it should be pretty rubbish. Oh yeah, it's got no clarity, and it seems to think that, well, anyway, I can randomly go through these, but I could be kind of showing off. So if I test it, what I'm going to do now is I'm going to step through 600 cases, and you should see that basically these are in 6 mini batches, 1, 2, 3, 4, 5, 6, and you'd expect it to be kind of 50% certain, i.e. it hasn't got an idea, provided that I've got the right number of cases. So in mini batch 3 I've got 47 fighting, in the previous one I had 42, in mini batch 4 I've also got 47, so I've got slightly fewer fighting, but in mini batch, oh, that's mini batch 4. Anyway, roughly I've got about 50-50 in each, and there's no real distinction. It has no real way of telling which is fighting or dancing because there's no trained parameters. But if with neural networks, if you run a lot of cases past the neural network, and these are supervised cases in that I've already specified what's fighting and what's dancing, then it'll improve. So at the moment, training accuracy 52, test accuracy 45 is rubbish. 50-50 would be kind of what we expect. So I'm going to initialize it again, and I'm going to run it with quite a steep learning rate. I've switched off the generative patterns there. That's just a little bit of VBA because it's heavy on the code, and it's now cycling through these cases. It's got to 60 different iterations, but it's running them as mini batches. The model I showed you on the mod tab has got 100 cases in one go, so each iteration is 100 cases, and then updates the weights. And what you're seeing here are the weights, the learned parameters actually being updated. So this is the actual hidden layers, or the parameters that equal the kind of y equals mx plus c. I don't know if you remember that equation. These are the M's, the gradients for the layer 1, layer 2 and layer 3. Layer 1 is 48 inputs. I had said it should be 40, but I was a little lazy when I categorized these arms and I double counted the pelvis and neck. So 48 inputs. I've got 15 neurons in the first hidden layer, 10 in the second hidden layer. Yeah, so 48, 15, 10 in the second, and then oh no, that must be 5 in the second, and then that comes down to 1. So the final layer is a binary classifier, and you can see that the gradient's flickering about because it's kind of working towards minimizing the difference between what I thought and what Excel thinks. That's the loss function, and this is going into a momentum layer, and that's effectively an exponentially weighted view of these gradient layers. I've got the momentum factor set to 0.9, which should look back by about 10 gradients. What that means is, as you kind of use, if you use a very large learning rate like this, it pretty quickly saturates and it can't get the nuance of the function, so it's bouncing all over the place, and the gradient's going positive, negative. By using momentum, it flattens that out, and you get the minor general trend, which allows you to optimize it more quickly. But I think you start to see these go a little bit crazy because the learning rate is really too high at 1%. And so we should see a learning curve come down and then start to go a little bit crazy and end hopefully reasonably well. Let's see how it ends. We've only got 200 to go. The test, we'll run a test after this and let's see how that goes. So hopefully I'll remember to copy these numbers over to here, and then we can put the test in after we've learnt the model based on mini batch 2. While I'm doing that, I'll just show you what some of the other runs I did. Well, when I split it into mini batches, I saw learning rates that were crazily different, but reasonably consistent. So basically there was absolutely no consistency in the way that I had viewed the mini batches, the way that I'd categorized fighting or dancing. We've only got 50 more to go, so I'll just hang around till we see that, and then we can set off and test it. 980, we should see a learning curve appear. It's taking a while to calculate these generative patterns, and look, perfect. It went a bit crazy towards the end, but at about 700 iterations, it learned the function reasonably well, so that's good. So now what I'm going to do is I'm going to, as I had said, copy these figures over to there, and I'm going to do a test. So what the test will do is cycle through each of the mini batches, and you'll see the associated generative pattern for mini batch 1, and it'll go through all of these, and it will see if there's been any learning has taken place. Oh yeah, 64%, so it's better than it was before. Let me just show you what happens. This is a slide of what happened if I massively overlearnt it with a low learning rate and 20,000 iterations. It learned to 100% accuracy, so it could absolutely decide from the training data whether it was fighting or dancing, but that's overfitting. The idea is that we're trying to get a general pattern of what is fighting and what is dancing, and the interesting thing about that is, humans can't actually describe why they think somebody's fighting or dancing. Is it the hips, the spine? Is it the way that they are looking at each other? But you can fairly quickly identify the difference between the two. Okay, so that was a pretty quick run. It was on batch 2, so batch 2's got 80% accuracy, overtrained. But the others have definitely kind of learned something about the nature of fighting and dancing from the 100 cases there. So I've moved my accuracy up to sort of 68, 64. As I say, I can go quite a bit further than that. And that's really all I've got to kind of say on this. It's a 3-layer neural network. It's fairly simple. I spent a while making the test data, and if I look at that not as trained examples, but just as random examples, you can see that just about anything can come up. If I run those random examples through a neural network, and this is just looking at the parameters that were learned, but the neural network is here with the single input vector, activation function down here, y equals mx plus c here. This is the m, this is the c, and then there's layer 2 and layer 3. And this is now completely random figures that have not been categorized by a human, but this is what the spreadsheet thinks. So if I step through a few of these, you'll see if there's any general Oh, interesting. It thinks they're fighting. Spreadsheet thinks they're fighting. It thinks they're dancing. I wonder why. Could be the legs. Thinks they're dancing. It thinks they're dancing. Thinks they're dancing. It thinks they're fighting. I would have said there was a hoedown or something. Or it could be an aggressive pull on the arm. Who knows? Anyway, it's interesting, I think. And if you have any interest in this, let me know. I'd be delighted to share the spreadsheet. I'd be delighted to get other people categorizing it and see if they can make sense of this categorization better than my spreadsheet can, which is all on sheet and actually very simple. I shall leave it at that.